Okay, these notes are going over our last set of proof vocab. Our essential question is, how can I use geometric vocab to complete triangle, transversal, and other polygon proofs? Our first vocab term is the definition of a regular polygon. What we know about if a polygon is regular, that means that the figure has all sides and angles congruent. So this is a regular heptagon. That's my given. So that means that every single side is congruent to one another. And then that also means that every single angle of the heptagon is also going to be congruent. Now sometimes you can go ahead and mark all this information, but if you notice what I'm trying to prove, these sides right here don't have any triangles on them, so I'm not going to be using this side of the heptagon. I'm going to be focusing over here. Second thing that you should notice is that when we are trying to prove something, we are not proving two triangles are congruent. We're proving two segments are congruent. So that whatever I'm trying to prove, we can always put that down here at the bottom. I am trying to prove that AH is congruent to BH. And the only way that we can prove two segments like this is congruent is by using CP, CTC. So what I need to do in order to use this, so this right here says that if I have two triangles that are congruent, I'm going to be able to prove that these other parts are also congruent, AH and BH. So these two triangles is what I'm looking at, and my goal is to figure out, is this triangle congruent to this one? Because if these two triangles are, then I know that these line segments are also congruent, using the corresponding parts of congruent triangles are also congruent. So in order to use this, I have to have a triangle is congruent to another triangle, and I need to figure out what that is. So I'm trying to figure out, are these two triangles congruent, so I can say that these two things are congruent as well. To get started on this, I've already marked them, but I'm going to go ahead and put my givens on my proof. So I'm just going to copy them down. A, B, C, D, E, F, G. That's the first 7 letters of the alphabet because a heptagon has 7 sides. And that is given. And then we know that angle AGH is congruent to angle BCH. So let's mark this on our page as well. So we know that angle AGH, so that's going to be right here. I'm going to use 2 arcs for that. Is congruent to BCH, so right here. Okay, so let's, I have that written down. So the only other information I have to go off of right now is that this is a regular heptagon. So let's take a look at these two triangles and see. So I was able to mark that this side and this side are congruent. GA is congruent. This side is congruent to BC. And I'm going to use the definition of a regular polygon. Okay. And so then I'm going to look to see, is there anything else I can do? Right now I have a side and an angle. No, this doesn't count because it goes across 2 of the shapes. Neither does this because it cuts all the way across. So it doesn't talk about this shape, it talks about the whole thing, and that doesn't work. If you notice right here in the middle, we have vertical angles. So that is angle AHG. It is congruent to angle BHC, and those are vertical angles. Okay, so then what I can do here is I have angle side angle, so I'm going to use that to prove that triangle AGH is congruent to BHC. Okay, going on to substitution. Substitution is exactly what it sounds like when we refer to substituting in algebra. So if two things are equivalent, I could take this thing out and swap it in for it. So I would have, instead of A plus B equals C, if I swap these two out, it would say D plus B equals C. So I'm going to do some swapping things out right here. Now there's no given, but if I look at this triangle, I see that I have here, I know that angle 1 plus angle 2 plus angle 3 equals 180 degrees. And we know that because of the triangle sum theorem. That's one fact that I can pull from this. The second fact is right here. I see I have a linear pair. Angle 3 plus angle 4 also equals 180 degrees. Definition of linear pair. So here's where the substitution comes in. This equals 180. This equals 180. So what I'm going to do is I'm going to scratch this out, and I'm going to plug in the 3 and the 4 that are equivalent to 180. So we can say that angle 1 plus angle 2 plus angle 3 equals this right here. Angle 3 plus angle 4. And that is my substitution. Okay, next if you notice this, when you look at it, it looks a little bit weird because there's angle 3 on both sides. So let's get rid of one of those. I'm going to do this more algebraically. I'm going to use inverse operations to get rid of that. What you do to one side, you got to do to the other. So if we notice, these both cancel out. So that leaves us with angle 1 plus angle 2 equals angle 4. And this right here, the reason is going to be my subtraction, my inverse operation subtraction. That's called the subtraction property of equality. Okay. Going on to the back, we now have the transitive property. The transitive property is a little bit similar to the substitution, but what makes it different is that the transitive, we are chaining a couple things together. So here's my example. A equals B, B equals C, and C equals D. So what the transitive property means is that the first term is also going to be equivalent to the last term. And it could be however many long. It could be short, it could be super long, doesn't matter. Okay, so I'm going to go ahead and write down our givens on this one. And there's two givens. You can write them down on one line like I did, or you can stack them on top of each other and do 2 lines. That's fine. This proof is a little bit different. It has transversals in it. We're not going to be dealing with triangles. When we are dealing with transversals on our proofs, that means that our vocab is going to be stuff like angle relationships, such as vertical angles, linear pair, alternate interior, alternate exterior, corresponding, and consecutive interior. So what I'm going to do is I'm going to try and chain these things together. So the first thing, and I'm trying to go from angle 1 to angle 4 to prove that those are congruent. So the first thing I'm going to do is go from 1 to 2. I know angle 1 is congruent to angle 2 because these are vertical angles. Okay, then I'm going to go from 2 to 3. I know angle 2 is congruent to angle 3. These two angles are called corresponding. Okay, so the 2 and 3 are corresponding angles. And then 3 and 4, these guys, they are actually corresponding as well. But they just have different transversals. So the first one, here's my transversal, slides along CD. My second transversal is GH. So those are corresponding, so that's angle 3 is congruent to angle 4. Okay, so what this all means, 2 is congruent to, or 1 is congruent to 2, 2 is congruent to 3, 3 is congruent to 4. Therefore, I can say that angle 1 is also congruent to angle 4, and that is my transitive property. Okay, and then the last word on this page is the segment addition postulate. Is exactly what it sounds like. What it says is that if I take 2 segments and add them together, they're going to be the same distance as the entire segment. So segment AB right here, if I add segment BC, I can rename that and call it angle A, or segment AC. Okay, so we're going to go ahead and start with our proof on this one. Go ahead and put your given on there. We know that AB is congruent to BC. And if you want to on these, you can also mark this information. So I know that this is congruent to that. Another way of saying that is B is the midpoint. That is something I could also say. And so here's what the segment addition postulate says on this. That would say that AB plus BC equals A to C. That's my segment addition postulate. Okay, and so on my segment addition postulate after that, so what I have to go off of is that these two things are equivalent. So what I can do is I can take these two and I can swap them out for each other. So what I'm going to do is I'm going to substitute in, I'm going to erase out BC, I'm going to take BC out, and I'm going to plug in AB. AB and BC are equivalent to each other, so I'm allowed to do this substitution right here. Okay, and the very last thing is I'm going to simplify this. If I have something like x plus x, that's the same thing as 2x. So that's what I have here. I have AB, and I have two of them, so I can rewrite that as 2 times the segment of AB equals AC. And that is how I get to my proof. The step that I'm going to call this, I'm just going to call this simplifying. And that is all the vocab that I have for you. Make sure that you practice as many proofs as possible. That's how you get better at proofs.